Right, previously in our class we learned that there are classifications. An IP address is classified so that according to the user's need, IP address can be distributed. That avoids wastage of IP address. For someone who needs very less number of IP address, a class C range will be given. A class C address will be given. Class C network will be provided. For example, if an organization needs 200 IP address, they will receive a network ranging between 192 to 223. For example, if someone gets this 193.1.1.0, the default mask is up to here, 255, 255, 255. This means that in the above 4 octet, 3 octets are network, and this octet means this one is free to use for providing unique IDs to computer. For example, the first computer will have 193.1.1.1. So this one indicates the first computer, and the second computer will be 193.1.1.2, 193.1.1.3, goes like that. Up till where? Till you reach 193.1.1.2. 55 is not a usable address. Likewise, 192.1.1.0 is not an usable address. So, how many IP addresses you get? 255 minus 2. Actually, it's not 255 minus 2, it's 256 minus 2, which is 254 IP address. In another word, if I need to write this, I should write like this. How many bits you have here? 8 bits. So 2 to the power of 8 minus 2. 2 to the power of 8 is 256. 256 minus 2 is 254. So from 1 to 254. From 1 to 254 IP address this company will receive. Any question?
No, sir.
All right. Now I'm going to give you a small assignment to do in the class. 10.0.0.0, 172.0.0.0, 192.0.0.0, 200.1.0.0, 128.0.0.0. Right? And then 225.0.0.0. What you need to do is you need to write the subnet mask for this, and then what will be the first IP of this, what will be the last IP of this, and what will be the broadcast IP of this. I told you this one is not an usable address. Why? Because it's a broadcast address. The last address, when all the host bits are on, you get 255, right? When all the host bits are on, 8 bits are here. When all the host bits are on, you get 255.
So in this equation, where do the 2 come from? The -2?
This -2 is because you don't use this as the host IP and this one. This and this we don't use from 256.
Okay.
That's why. Now, you need to fill all these things now. What will be the subnet mask? Okay, one more thing. What class it belong to? What class this belong to? What will be the subnet? What is the subnet mask of all this? First IP, last IP, and broadcast IP. I'll do one. For example, I'll do one. This is class A. Subnet mask is 255.0.0.0. The first IP is 10.0.0.1. The broadcast is 10.255.255.255. Means all the bits are on. That's why you got this. And the last IP is 10.255.255.254. Yeah, 254. This is the last one. This is the first one. This is the broadcast one. This is the subnet mask of it. This is the class of it. Okay, so I'll meet you again in another 1, 2, 3, 4, 5 minutes for each 1 minute. 5 minutes. Here we go. This is 172. 172 is in class B, the range. In previous class we saw the range is like this. Class A is 1 to 126, and class B is 128 to 191. Class C is 192 to 223. Class D is 224 to 239. This is how the range we saw. And we also saw how this is derived. Huh? Now let's go back. This is 172. This 172 is in between these two numbers, which means B, class B. And the mask is 255, 255.0.0, because in class B we saw 2 octets are given for network. So this is the subnet mask of that network, which means this is the network portion and this is given for the host. Now what will be the first IP? The first IP will be 172.0.0.1. What will be the broadcast? 172.0. Look at this. Why I put 0 here? Because it's masked. The first 2 octets are masked because it's class B. So you cannot put 255 there. And 255.255. What will be the last IP? 172.0.255.254. Right, shall we go to the next one?
Yes.
Right. Now 192, if you see 192 is class C. 192 is class C. Any number between these two is class C. Class C. Class C, we saw in the previous class that the mask should be 3 octets. There's 3 octets are given for network. And then the first IP is going to be 192.0.0.1. Listen carefully. This is class C. 3 octets are network, which means this 3 octets or network octets. This cannot be 255. So the broadcast will be 192.0.0.255. This is the broadcast. The last IP will be 192.0.0.254. One less than this. So you got first one, you got last one, you got the broadcast. Any question?
No, sir.
Let's move to the next one. This is again class C. You see, any number between 192 to 223 is class C. So this is class C. I could see here. Now the mask is again same thing, 255 or 255, 255.0. The first IP is going to be 200.1.0.1. See, in this 3 octets are network. So the broadcast will be 200.1.0.255. And the last IP will be one less than 255, which is 200.1.0.254. And this is 128. I have written 128. 128 is class B again. So class B mask is 255.255.0.0. The first IP is going to be 128.0.0.1. And can someone say what will be the broadcast of this? What will be the broadcast of this?
128.0.255.255.
Right. And one less than this is 128.0.255.254. 225. This is not at all valid. You see, we don't have 225 as a IP address in ABC. 225 belong to multicast. Class D belong to multicast. It's not a valid IP address. So just for testing, I gave you. You should have not filled anything here. You maximum may say like this belong to class D multicast range. So there is no first IP or last IP or broadcast IP for multicast range. Okay, so 225 is not valid IP address, valid network. It is not a valid network. It's a multicast range. Fine. Hope you all did this correctly. If you have not, please copy. Ask question. If you have any question, please ask. Take your time. Copy this and ask me a question.
So just if it is class C, it's easier to write because you know that the first 3 octets are already reserved for network. And it's just the last octet that you change, right? The number changes for host. So when you ask for the first ICP, for first IP, it's just the last octet that changes, and that's 1. But if it is class B, then it's 2 octets are reserved for host and 2 are reserved for network.
Yeah.
So I just got confused. So if you say 172,
Yeah.
I got confused with the FIP. I thought it is 172.0.1.0 instead of 0.1.
Okay, let me answer that question. It's a nice question. Why you got that confusion? It's because I failed to say this. You see, um,
It is definitely easier with class C because it's just
I
one
understand,
option.
but whether it is A or B or C, the host will start from small to big. For example, if you are given 3 bits, is this small or this is small? Which one is small? This is small or this is small?
The second one, 001.
Yeah, 001, because this means 4 according to binary.
Right.
1, 2, 4 doubles. The first bit is 1, second bit is 2, third bit is 4. So you always start from this end. 172.0. These are the host bits.
Yeah, I'm getting there. I'm getting there.
Okay.
I'm just,
You need to go through the yesterday's class video
yeah.
and also today's class video to get more in depth on this. Next, I told you we have only 32 bit to supply IP address to this entire world. So it needs to be wisely handled to meet the need. One of the wise move that they made is classification. Secondly, they gave 2 schemes of address. One is public address and private address. The private addresses are the one which anyone can use without anyone's permission. The address that I use, you also can use. It won't conflict because they are private. For example, if I have 1,000 employees in my company and you also run another company with 1,000 employees, you and me can have same IP address inside our organization. My employee first computer 10001, 10002 second computer, 10003 third computer. So this is the IP address of my company network switch. Likewise, you may also have the same 10001, 10002, 10003. All of this are connected to one single switch there. See, this is my organization. This is your organization. We have same IP address and it won't conflict. Whenever we talk to public, we will drop this ID and take the public ID. And the public ID will be assigned to our edge router. And this edge router is what connects us to the internet. Likewise, your company also has got an edge router. And your edge router is connected to internet. You see, even if you have 1,000 computer, you don't need 1,000 public IP address. You need just one public IP address. Say, for example, 1.0.0.1 is given to you. Another public address, let's say 5.0.0.1 is given to you. 1.1.1.0.0.1 is given to me. My public IP address is 1.0.0.1. Your public IP address is 5.0.0.1. Even though I have 1,000 computers, I no need to buy 1,000 IP addresses. 1,000 IP addresses is not necessary. Only one is enough. 1,000 private IP addresses I have, for which I no need to pay anyone. Within an organization to communicate, this IP address is more than sufficient and it is free. It's free. Private IP addresses are free to use. You can use any private IP addresses and you can communicate within your organization. And whenever you are going online, means whenever you are going internet, whenever you are trying to surf internet, whenever you are going to communicate to another network, for example, you want to talk to my computer and my computer wants to talk to you. In that case, this original identity 10003 will be dropped when the packet goes out. Up to here, it will come like I'm coming from 10003. But when it leaves the network, it will go with this ID 1.0.0.1. So all my traffic in the internet, all my traffic in the internet will be seen as if it is coming from one particular IP called 10001. All your traffic's coming out, according to the internet, it is coming from 5.0.0.1. So you need only one IP to be identified. Your organization no need of 1,000 IP address, just one IP address. See, this is how we are managing with the 32-bit. Just 32-bit, how the entire world is communicating. It is because you have a lot of private IP address inside your organization to communicate, and only when you are trying to go online outside the organization, you use the public. And the public IP address is paid one, and we do NATing here. We call it as network address translation. We'll talk about this in detail later, network address translation. So what happens really is whenever you are trying to go Google from here, Google, it's a public network you want to reach. Google is public network. So the original identity 10001 is dropped and this identity is taken and it goes to Google. And Google responds to this address and the response comes back. We call this process of changing the original identity, changing the private IP address to public IP address as NATing. Now let me write down the range of private IP address. If you don't have questions, kindly mute your mic because I'm getting some echo. Thanks. Now the private range of address. Ten zero 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 till 10.255 or 255.255 is a private IP address. This is a private IP address. This is again another range of private IP address. So we got one private range in class A, another one in class B. There's another one in class C. So you don't think it is one, it's 16 to 31. So there is a range. Though it starts with 172, in 172 You got 16, that's separate network. 172, 17 is another network, up to 172.31. Likewise, 192.168.0.0 till 192.168.255.255. If you notice here, this is host. We all know host. But this is not host, network. So you got 255 private networks that begins with 192.168. 255 private networks. In each private network, you got 255. It's 256 minus 2, which is 254 IP address. For example, 192.168.100. In this, the first IP will be 1, 192.168.100.254 is the last IP, and 192.168.100.255 is the broadcast. So here we see 100 is one of the network. In that network, you've got 255 IP. So you have 0th network, you have first, second, third, fourth, fifth, 100, 101, 200, 255, up to 255. These range of addresses are private. Rest of all the addresses, all addresses are public. So if you know only this much, it's enough. I know what is private. The other things are public. For example, 172.33.0.1. Is it a private address? No. Look at this. 33. Private IP address ends in 31. 172, 31. But here what I have written is 173. This is a public example. So all other addresses except these range are public. So this private range of address, anyone can use inside their organization. Any range you can use. You can use 10 range or 172 range or 192 range, depending on how big your network is. You decide one, A, B, and C, class A, B, and C. You don't need anyone's approval to use this. Your company needs to approve, but outside the company, no one you need to ask. See, if you are using a public IP address, you should use the one which is given by the service provider, the internet service provider. That is public IP address. But the private IP address, which you are going to use within an organization for all these 1,000 computers, your company only need to decide. You can decide to use 10 network or 172 or 192, it's up to you. But these addresses are private. They are not going to communicate to public network. If you want to communicate to public network, you need a public IP address. But you don't need plenty, you don't need too many, you need just one. So even if you have 10,000 computers in your organization, you need only one public IP address and 10,000 private IP address. So we are saving 9999 IP address, public IP address. Out of 10,000, how many public IP addresses you got? Only one. So for the entire organization, just only one. You no need to buy 10,000 public IP. You don't need to buy 10,000 public IP. Just buy one. You save 9999 IP address buying. This way, the 32-bit is now available for the entire world. So each organization, if you give only one IP address, only one public IP address, definitely you don't need too many. You can somehow manage to use the 32-bit for the entire world. But even though we have all this thing, we already finished using all 32-bit IP addresses. That is why we have moved to another version of IP address called IP version 6. IP version 6 is not just 32, it's 128 bits in size. 128 bits in size. Yeah, we'll go back up. So private addresses, because we have private IP addresses, we don't need too many public IP addresses. In that way, we don't use much public. We save a public IP address so that others can use. All right. Now we copied this. 492. This is one of the important topic that we should know. The private range. So that when you see an IP address in some topologies, you will know whether it is private or public. Just by looking into the number, you will know it. Any question?
No, sir.
All right. And you remember I told you 127 is not again an usable range of address because it is loop back. Like loop back, there is also another address 169 or 254 range address. This is also not a usable address. Usable subnet. Why? This is APIPA. This one is Lubeck. This one is APIPA. What is APIPA? You see, the A stands for automatic. P stands for private. IP, Internet Protocol. A, address. Automatic private Internet Protocol address. See, this is a private address which is automatically generated for the Internet Protocol to use as an address. Meaning this is not a public IP address. Meaning this is not an address that you will be using to communicate outside the world. Sorry, outside your network. This will not be used for communicating to outside world. And why do you need this address? What is the purpose of this APIPA address? And if it is automatically generated, why it is generated, when it will be generated? Let me explain that. You see, you got a server, DHCP. DHCP stands for Dynamic Host Configuration Protocol. Let me explain you first the DHCP, then I'll go to Apipa. We have something called DHCP, Dynamic Host Configuration Protocol. We will run that protocol in a server. The purpose of this DHCP is to provide IP address to whomever asks. Whoever asks. For example, here is a computer just turned on. Computer A is just turned on. As soon as you turn on, this gets an IP address from DHCP server, like 10.0.0.1. As soon as you turn on this, the server gives 10.0.0.2. As soon as you turn on this, the server gives 10.0.0.3. How? Because this is designed, configured with a pool of address. 10.0.0.254. So you have a pool of address here from which the server will give one IP address to each client. These are all called as DHCP clients because they receive IP address from the server. So how many clients you can have? You can have up to 254 clients. Right now you have 3 clients and you got 3 IP addresses for each client. One IP address is dynamically configured. See, in a large organization or small, whether it is large or small, nowadays we don't assign IP address to our laptops. You just open your laptop, you get the IP address from the DHCP server in your home, that small access point, from where you get the internet. That is an DHCP server. You close your laptop, when the laptop is off, you don't have an IP address. It is released. It is given back. So that another laptop, whoever comes online, can get the IP address. And when you open your laptop and on the laptop, another IP address comes from the DHCP pool. And now you close the laptop, you go to airport. In airport, you try to use the internet, the free internet in airport. Assume you're planning to use a free internet. You open the laptop again. You get an IP address from the DHCP server in the airport. The airport's DHCP server provides an IP address. The IP address that you got in your home network, the IP address that you got in the airport will not be the same. Because it's from different DHCP server. But the laptop is same with the different IDs. See, IP address is a logical address. It will not be always same. When you receive an IP address from DHCP server, even though you receive it from your home network, today you will get one IP address, tomorrow you may not get the same IP address. You'll get another address from the pool because the address that you used yesterday is given to someone else today. In short, what I am saying is, DHCP server provides IP address to you for communication without any pain. You don't need to have any pain of giving an IP address. You don't need to take the pain. So this DHCP server provides an IP address, a unique IP address which is not used by anyone else, because DHCP server knows what all IP address it has already given to others. So whatever is not given will be given to you for communication. In your home, if there is 10 computers, cell phone is also nowadays a computer. It needs an IP address. So don't expect every day your cell phone will get the same IP address from the DHCP server. No, different. Because the address that you were using yesterday, now it is given to someone in your home today. Now this DHCP server, easy our work. You no need to go to every single computer and put the IP address, a unique IP address, automatically assigned. But what if the DHCP server is down? What if this connection is broken? What will happen? These PCs cannot reach the server. These clients will not be able to reach the server because there is a break in the wire. As a user, you will be expecting IP address for communication, but unfortunately there is a break. Now you call the technician. Now you are the technician, you are learning this networking course. You need to troubleshoot the problem. You're not going to communicate to anyone because there is no IP address for your computer. How we will check that there is no IP address? When you go here, click on properties, and then you see there's an IP address 192.168.1.63. This will not be there when you check. Instead, what you will see, instead of this valid IP, this is class C IP address. Instead of this, you will have an IP address in this range 169.254. Dot maybe some number like this. Can be any number. If you see this number instead of a valid IP address like this, if you see this number 169.254, you should understand that these clients cannot reach the server. Server cannot reach the client. So this address called APIPA 169.254.254.x.x. This range of address called APIPA, Automatic Private Internet Protocol Address, dynamically get generated if the DHCP is not providing IP address. When these clients come online, when you turn on the laptops, they look for the DHCP server to provide IP address. They wait, and they wait. And there is a time period, there is a waiting time. When the waiting time expires, this is dynamically generated. When the waiting time expires, when the server doesn't respond on time, this 169.254.1.1, 169.254.1.2, 169.254.1.2. This is dynamically generated by the operating system of this laptop itself. It's dynamically generated. And this address is not used for communication. This is just to tell that the DHCP server is not responding. Now you need to go and troubleshoot the DHCP server. You go and check whether this cable is fine. The cable is broken. Replace another cable. Sometimes the problem may be someone mistakenly offed the server. The power is off. Go and on it. So whenever you see this number, when you troubleshoot network, whenever you see this number as an IP address 169.254, if you see 169.254 instead of this valid IP address, if I see that number, then I am sure that the problem is with the DHCP server. I'm sure that the DHCP server has not provided me the address. I need to troubleshoot with the DHCP server, not my laptop. 169.254 address is dynamically generated by your operating system to indicate that the DHCP server is missing. DHCP server has failed to provide an IP address. Just to indicate you, this address, private IP address, is dynamically generated. So 169.254 is also like a loopback address. See, this cannot be assigned to an IP. This cannot be assigned to a computer. Likewise, this cannot be assigned to to any computer. This 169.254 cannot be assigned manually by us. It is only to indicate the DHCP server is missing. This will come automatically. This is generated by the operating system. Right? So, 169.254, what class it is actually belong to? Sorry.
Class B.
So in class B, this particular range of address is not a valid address. So even though I said in the early session, like class B is 126 to 191, in that 169.254 is an exceptional. It is APIP address. So 169 in the middle is not a valid range of address. It is given for APIP. All right. So these are the basic things that we need to know about IP address. We have classes A, B, C, and we have private and we have public range of address. And we got loopback address and APIP address that cannot be assigned to any device. Loopback address, we ping and verify whether the OSI layer is fine with us, meaning we got the network drivers properly configured. APIP address dynamically comes to tell you that DHCP server is missing. So what we need to learn next is a big topic called subnetting. Subnetting is, as the word says, subnet, breaking down one network into multiple networks. For example, 10,000 is one network, but I can break down by saying 10.1, this is one network, 10.2, this is another network, 10.3, this is another network. This is what we call the subnetting, breaking down one network into multiple networks. Now, how to do this, why to do this, all those things we need to see. But it's a vast, big topic. I think I have to start fresh in next class. It'll be too much if I start now. So we stop here today.